Okay, so some more of our rules of indices. This time we're just going to be looking at problems where we're combining at least two of our rules, if not more. So we're just going to jump straight into it. So the first thing I see here is that I've got a multiplication going on. The moment I see that, I know that one of the rules I'm going to be using is the very first rule, where we add the powers. And the next thing I spot is this fraction line here. So instantly that makes me go, well, that means I'm going to have to use the second rule as well, which is just the opposite of the first rule, where we just subtract the powers. So I know instantly that these are the two rules I'm going to have to use. I'm not going to have to worry about anything else. So to start off with, the best thing to do is to actually just neaten up the top of our fraction and neaten up the bottom of our fraction, and only then will doing our second rule be easy to do. So adding my powers, and remember, when there's nothing there, it's going to be a 1. So I've now got m to the power of 5 over m to the power of -2. And now I can take away my powers. So 5 take away -2. Well, that's just going to end up being a positive, because two negatives make a positive. So I've got 5 plus 2. So that's going to be m to the power 7. And that's it, all simplified. Okay, next one. So again, similar before, I see I've got this multiplication here, so I know I'm going to be using that one where I add the powers together. I see that we've got this fraction line again. So I know that I'm going to be taking away the powers. And I see on the bottom, I've got brackets with more than one term in it. So I know I'm going to be using my fourth rule. But it will also relate to my third one as well. So these are all the rules we are going to be working with in this example. So again, same as before, going to be neatening up that top. So I'm going to do my big normal numbers multiplied together. So 3 times that 4 is going to give me 12. B, and then I'm going to be adding those powers. Then the 3 inside at the front is going to be affected separately with that squared. And then, oh, that's the complete wrong thing. Then b cubed is going to be affected by that squared as well. So b to the power of 3 times 2. So neatening that up, we've now got 12b to the power of 8 over 9b to the power of 6. So again, like I did before, if I want, I can just sort of separate it out like this, just so it can make it really, really clear what simplification is going to be going on. So first, looking at my fraction here, where I can divide both the top and the bottom by 3. So that's going to be 4 over 3. And that'll be b to the power of 8 take away 6. So my final answer is 4 over 3, b to the power of 4. Okay, next one. I've got evaluate 8 to the power of -2 over 3. So first thing I can see here, we've got this minus sign going on. So that means I know we are going to be dealing with this rule, That was rule number 6, I think, if I remember. So when I have a negative, it's going to be turning it into a fraction. And then the other thing I can see, oh, done it again. I can see we've got a power that is a fraction. So remembering my little thing to help me remember where everything goes. The bottom is the root and the flower is the power. So just drawing out my little flower again, just as a quick reminder. So putting that into use, gonna have my root sign. 8's gonna go in there. The bottom is the root and the flower is the power. So the cube root of 8, well, if I was unsure, I could work my way up. But 2 times 2 times 2, or 2 times 2 is 4. Times that by 2 again, gets me to 8. So that's going to be 2 to the power of negative 2. Now I'm going to use this rule here. And it's going to become 1 over 2 to the power of 2. So it'll just be 1 over 4, or a quarter. Okay, next one then. I've got 3m to the power of 4 times 2m to the power of negative 4. So I'm right now looking at this. The only rule I can seem to identify is that an times am1. So I'm just going to do that first. So 3 times 2 gives me 6. And I'm going to have m to the power of 4 plus negative 4. So it's going to be 6m to the power of 0. Now at this point, suddenly, I can see another one of my rules. Anything to the power of 0 is 1. So that means this bit here, just the m to the power of 0 is 1. So that means I've got 6 times 1. So that's just going to be 6. And I believe this is the last one. Yes, it is. So last one, looking here, again, because I see that multiply there, I know I've definitely got my first rule. Because I've got this division sign going on here. And now I've got my second rule. And because there is this square root sign down here, I know I've also got to deal with my 7th rule. Again, the bottom is the root and the flower is the power. So neatening up the top first, that's going to be 4m to the power of 2 plus 3, which is 5. Now, this bottom part, right now, I can't really do much while it's in that square root form. It's going to be a lot better for me if I put it as a fraction. And remember, if I have this square root here with absolutely no number here and no number up here, well, for starts, square root means something times by itself twice. So that's going to be 2 in there. And then up here, that would just be a 1. So that means I'm going to have m to the power of a half. Then using my second rule here, that's now going to be 4m to the power of 5. Take away a half. So that'll be 4m to the power of, multiple ways you can put it. You can either do it as 4.5, or you can have it as 4.5. Either works, but the key thing is that I've taken half off of that 5. So those were just a few examples of where we can mix up our rules of indices. And again, good thing is to just try and identify the ones you know, and at least attempt the ones that you can recognize, even if you don't manage to simplify the entire thing. But until then, see you later.